Okay, the purpose of this video is you are going to learn to draw conclusions based on a geometric figure and some given information. Yesterday we worked on drawing conclusions using algebraic properties, and that's very intuitive to you guys because you worked a lot with that in algebra class. So it's the same idea, and eventually this will become as obvious to you as what do you do when you have 2x plus 4 equals 10? You subtract 4 from both sides. So given information here is anything that's in your picture, as well as any statements that are given to you. You're allowed to use that, and I want you to make the most specific conclusion possible. So you might want to pause and jot that down on your paper. And then we're going to try to not focus on this entire picture because there's a lot going on. We're going to try to focus on, because sometimes we can draw more than one conclusion. We're going to try to focus on this statement. I want you to read this as this is the hypothesis of a conditional statement that I'm about to make. If line BD or ray BD or segment in this picture bisects angle ABC, then the S stands for statement. Statement can be hopefully an equation would be my first goal. Sometimes it can't be an equation, but can I make an equation that's true relating either segment measures or angle measures based on the given information? So if BD bisects angle ABC, I'm thinking about what bisect means. I'm also highlighting what's talked about in that given information. There's angle ABC, and then I've got BD, which is bisecting it, and I know bisecting creates equal angles. So my most specific conclusion that I can make here is that angle ABD is congruent to angle CBD, or there's another way we could say it. We could say that the measure of angle ABD is equal to the measure of angle CBD. So just make sure you're using the equals if you're putting measure, and if you're not using the measure, you're using the congruent symbol. And either of those, both of those come straight from my definition. So for the reason, this R stands for reason. We're going to force ourselves to start giving reasons because now we're using deductive reasoning. In this specific problem, with this particular picture, I know that BD bisects angle ABC because my definition of bisects, or you could say angle bisector if you want to be specific, says that in every case, if you have a ray bisecting an angle, congruent angles are created, or equal angle measures are created. Therefore, in this particular problem, I know it works out that way. So there's your deductive reasoning, going from general rule to specific example. I just want to make a quick comment here that we could certainly say a lot of other things in this picture. So if you're thinking something like measure of angle ABD plus measure of angle CBD equals measure of angle ABC, part plus part equals whole angle, I absolutely agree that that statement I just wrote in blue is true. And we could justify that. That would be our angle addition postulate that makes that true. And that's not going to be entirely wrong if I make that my conclusion and then give this as my reasoning. The only thing I'm going to say is let's try to make the most specific conclusion possible. And I think the red conclusion is more specific to what I'm told about the word bisects versus what I have in blue would always be true. So keep it in mind because a lot of times we need more than one conclusion. But if we're just looking for one, let's start with the most specific. Then we can go back and draw other conclusions. Okay, we're going to take a look at the same picture. So the picture's not going anywhere. But let's see how our conclusion that we draw differs if we have a different piece of given information. So that's point D up there. This time, I'm not talking about angles at all. I'm talking about segments being congruent. AD is congruent to DC. So those two parts are equal. And if you think about, if you heard what I just said, I said, oh, so those two lengths are equal to each other. I actually just made a conclusion there because in my mind, I'm saying, if I know segments are congruent, then I know that their measures are equal, and I just said this, AD is equal to DC. What's my reasoning? As long as I can say why I know that's true, it's a good conclusion. That's the definition of congruent segments, that if two segments have equal measures, then they're congruent, or if two segments are congruent, then they have equal measures. So that would be one possible conclusion. I think there's a better one we can do, but that works. And the better one is, if they're congruent, what does that mean? And I'm going to call this sort of a backwards conclusion, because usually we start with the words, like we did in number 1, and then we make the conclusion. So here we had given information of words, and we made an equation from it. Here we're actually given some form of an equation. So what words could I say have to be true? What had to be true in order for that to happen? Because remember, your definitions work both ways. So I'm thinking if AD is congruent to DC, well, D has to be the midpoint, right? It has to be right in the middle. If I had told you D was the midpoint, you would have said AD is congruent to DC. So I'm going to actually say that my conclusion is D is the midpoint of AC. And my reasoning is definition of midpoint. So remember that R stands for reasoning, or reason, and your reasons can be properties. That's what we worked on in the previous video with the algebraic properties. They can be definitions, and that's what you're going to see a lot in this video. They can be postulates, would be the other thing that we have right now that would be good justifications. Okay, let's look at 2 more examples. So here's an example on the left, and notice we have no given information here in terms of words, we just have a picture. So it looks like T's in the middle of S and W, but I'm not told T's the midpoint. So I'm going to stay away from saying something like ST is equal to TW. And instead I'm going to say what's always true when I have a point between 2 other points. I could phrase it as, if I'm observing that picture, T is between S and W. So my statement, if I know this is true, then my conclusion that I can make is I can say if I add part plus other part, I get whole length. And I know I talked about this in the first chapter. My segment addition postulate is always true. ST plus TW has to equal SW. So that's kind of your safe option. Again, if I were told that T was a midpoint, then I'd probably be concluding that ST is equal to TW. But I don't know in this case that it's a midpoint, so I'm going to stay away from assuming that. And the last one here that I have for you is angle ADC is a right angle. I like this one because there's a lot going on in this picture, and you're automatically making like at least 3 conclusions in your mind. So we're really going to focus on what these words say. That we've got a right angle. What conclusion can you make right now? What are you thinking when you hear the word right angle? And I already know what you're thinking. You're thinking 90 degrees. So my first conclusion that comes to my mind, if I know this is true, then the measure of angle ADC is equal to 90 degrees. To be honest, I didn't even need my picture for that, because when they tell me it's a right angle, my definition of right angle tells me if any angle is a right angle, then its measure is 90 degrees. Done. Okay? So that's my conclusion that I have. That's the first conclusion. Now, I suppose that you are probably thinking, I'm going to try to read your mind here, and I'm guessing that you're probably thinking, if that's true, then angle ADB, I'm just going to call that angle 1 for a second, and angle BDC, that you know a relationship between those, angle 1 and angle 2. If they make the entire angle, then together they're going to have to add up to 90 degrees. I absolutely agree with you. However, we can't go straight to saying something like measure of angle 1 plus measure of angle 2 equals 90 degrees. In terms of logic, you just did about 3 steps there, because you first recognized that measure of angle 1 plus measure of angle 2 equals measure of angle ADC. and you recognize that the measure of angle ADC is 90 degrees that we did over here. Therefore, measure of angle 1 plus measure of angle 2 equals 90 degrees. I don't know if you're seeing it, but you've got angle 1 plus angle 2 equals ADC. ADC equals 90 degrees. Therefore, angle 1 plus angle 2 equals 90 degrees. You're really putting together this statement and actually doing what we call substitution. So I almost did a mini proof right here, just to show you how these statements are going to eventually link together. This is a great example of first conclusion is we've got 90 degrees, definition of right angle. I use my angle addition postulate here if I were to justify this. I could say I did angle addition postulate. And then I really could say that I did substitution property here. And now I've given my reason on the left, my reason on the right, my statement on the left. And I start to link these statements and make what we call a proof. Okay, I'm jumping a little ahead of myself, but that was a great introduction for you. You're going to focus on what's my most specific conclusion that I can make, and how do I know?